Hello everyone, welcome back to my channel. Today let's go over a premium hard database question that I just solved on my own. So I'm really happy about this, and I'm super glad that I was able to come up with my own solution to this question without any assistance. So let me show you how I did it. This question is called Page Recommendations 2, number 1892. Lots of pieces of information in this question, so I'm going to walk you through step by step as to how I was able to come up with my own solution. So basically, you have a page recommendation system for a social media site, and I found it was easier to just look at the examples. So for each user ID, you have a page ID. So basically, each page ID is going to be the page ID that is liked by a friend, and this is a bi-directional relationship. So 6 is a friend of 1, 1 is also a friend of 6. So before we do anything else, let's go ahead and make a friends dictionary, default dict of type list, and let's do that bi-directional relationship. So you can think of it like a graph. Friendship user 1 ID, so friends of f dot append friendship from the user 2 ID, and then the other way around. Okay, so now that we have that out of the way, basically that's going to be the list we're looking for the friend of the current user. So it's going to be 2, 3, 4, and 6 for user 1. Those are user 1's friends. And then now we need to keep track of every page that that user liked. Okay, so let's call this liked. And let's loop over likes user ID. So liked of the user ID, they liked that particular page ID. Okay, so likes page ID of I. So this is not a bi-directional relationship, right? A page ID can't like a user can only like a page ID. Cool. So now we basically want to find for each user, okay, so all the page IDs for that user. And basically, first of all, you have to only include page IDs that are not liked by that user himself. So notice that 1, even though 6 liked 88, 88 is not included in 1. Cool. So now let's go over each user. So for f and friends, let's print f and friends of f. So you can see that, okay, default dict of type list. Let's see, why does this look weird? Oh, yeah, this is a default dict of type list. Huh, that is weird. Default dict list. Let's do this. Huh, why is this? So friendship user ID, user 1 ID, yeah, so friends of user ID 2 dot append f. Yeah, that's not correct. Something's weird going on here. So 1 append 2 dot append I. Huh. Okay. Default dict list. Maybe let's separate these out. Nope. That's weird. Oh, of I, not. So that particular cell, right? Okay, cool. So now we're talking. Okay. Okay, so you can notice that we don't care about 6 because 6 has 88. That's the only page ID these liked, but it's covered up by 1. So this list, for example, 4 has 3 of them. Let's go ahead and try to filter this out. Okay, so how do we find for each user ID which page IDs we need. So let's go ahead and say, let's also print likes of F. So that's everything that's possible. Friends of F, likes of F. Oh, liked. Sorry. Okay. So that's not correct because we're basically looking at everything that all these users liked. So let's go ahead and say total liked. And for friend in friends of F, so let's go ahead and print liked of friend. What is that? Friend like. So you can see 77, 24, and 88. So, and then let's call this, so for n in liked friend, if n is not in what you liked supposed to be likes of liked of F, that's you're the current person, not in you liked, then we can total liked dot append n. Okay, so let's print F and total liked. Okay, cool. So you can see that 4 is 3 and then 6 is nothing. So in this case, for example, well, first of all, let's make this a set. Oh, okay, cool. So 1, 2, 3, 4, 5, 5, 4, 2, 3, and 2. Awesome. So now we have to see for each one of these how many friends liked that page. So for T and total liked, let's call this count and let's go through. So for how many liked this page? So so for each page, I guess, so for, yeah, T in total like, that's the page, count for page, and then let's go through all the friends. So let's call this your friends equals friends of F. So for Y in your friends, if so, did they like this page? So if T is inside of liked of Y, that friend liked it, so it's count plus equal to 1. Okay, so at the end for each page, then let's go ahead and print the F, T, and the count, because that's going to be the count. How many friends like that page? Your friends like that page. And cool. So as you can see, that's correct. It lines up with what you see, and it says here you can return it in any order. Cool. So now we basically have our answer, and we can just gather the results. Make 3 arrays for 3 columns. Then we have a result. Set user ID to 1. Set page ID to 2. And then friends likes to 3. And then return that data frame. Okay, let's run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. Thank you for watching and stay tuned for more.